Hello, CP Finite Mathematicians, and welcome to one of our last chapters on logic. So, this is a different branch of mathematics, in that we are going to be getting rid of most of the numbers and dealing with logical reasoning. A lot of mathematics in the higher level is really just logic, and this is how all of your old school mathematicians went about things. So I may use an accent here or there. Some of you said that you'll be more likely to watch if I have an accent, so why not? So our first thing is some terminology. The central question, what is a proposition? How do you identify the type of proposition? And so forth. So first off, a proposition is simply a statement that can have one of two values. They are either true or, hey, false. Okay? Computers and everything technology-wise is based off true and false, essentially. We'll get into that later. Typically, they involve the words is, are, and was. Sometimes it's difficult to evaluate a proposition. Why? Because they can be unclear. Okay, maybe we don't know much about the background. Unclear meanings. They may be ambiguous. Ambiguous. Big words today. Big words today, but that's okay. And you may have differences in opinions. A lot of politicians, they have their propositions and such that maybe not everyone agrees with, but we are going to try and remove those in the mathematical sense. Okay. Also, shifting towards our new learning, we are going to be looking at symbolic. Symbolic logic. Okay, that is basically taking words and putting them into letters and allowing us to evaluate truths. Okay, and this is simply for the sake of arguing. Some of you like to argue with me, so now you can formalize your arguments with logic and make a more structured reason. Okay, so let's see. Counterexamples of propositions. So things that are not propositions are exclamatories, so things with exclamation points, imperatives, and also so imperatives are commands. Okay, commands, and also questions, interrogative statements. So questions, if you see any of these types, it's not a proposition. If you see a question mark, an exclamation mark, or it's a command. So for example, something that's not a proposition. So these are not propositions, not props. Okay, something like, where are you? Where art thou, Romeo, Romeo? Where are you? Where are you? Where are you? Okay, that's a question. You can't answer that with true and false, so it's not a proposition. Watch out! Okay, something like that. You can't answer, you're not going to be like, watch out! And you're like, true, okay? So if you can't answer it with true and false, it's not a proposition. And also a command like walk the dog. Go and walk the dog. Okay? That is a command. And you can't answer that with true and false, so those are not propositions. You'll have the question to analyze, is it a proposition or not? So if it's any of those three, it's not. So to determine if the following is a proposition, P, or if not, no. Okay? So the sky is blue. True or false, you could say true. So that one is a proposition. No, it's technically not blue, but we're not worried about the truth or the falsification. It's just, can we answer it with true and false? Apples cost $5 a pound. That is also true. So that is a proposition, okay? Maybe they don't cost $5. Again, I'm not worried about if that's really true or not. I'm just worried, can I answer with true or false? So that's just, can you answer with true or false? Can you answer true, false? Great job! That's an exclamatory statement. So that is no. That's an exclamatory. Where are you? Okay, no, because that's a question. Nice shoes. Spiffy shoes. No as well. I want a cookie. That is a proposition. You could say that's true or false. I personally don't want a cookie. It goes right to my thighs. Peanut butter cookies, I would take a peanut butter cookie, actually. So in that case, it would be true. The earth is flat. That is also a proposition that could be true or false. And now we know it's not, so we do know it's false. But as sake of being a proposition, it is a proposition. Okay. How do you get to Harrisburg? That is not because of the question. Do your homework. I wonder what that one is. That's a command, so also no. So things like do, those are commands, so those are not. All right. I'll be back. That is a proposition. Okay, because that could be true or false. Make me a sandwich. That's a command. So commands, again, are not propositions. My favorite movie is Star Wars. That is definitely a proposition. That's true, and that's always true. Always. The Force will be with you. Anyway, nachos taste good. That's a proposition. Now, it is an opinion, but opinions are okay. All right, same with Star Wars. That's an opinion, but it's still a proposition. You could say true or false. Wonderful weather we are having. No, because of an exclamation. The weather is wonderful, on the other hand. That's not an exclamatory statement, so that is a proposition. So these are very similar. One is a proposition, one is not. Where's my jacket? That's a question, so no. And it is cold. That is a proposition. It could be true or false. So basically true or false, if you can answer that, you're good to go. Wrapping it up here. So on the back, oh boy. Take a deep breath. Here we go. So compound propositions. Compound propositions is, I should say are, I guess, a statement formed by combining or negating a proposition. The connectives are the words either, the words or, the words and, but, and if, then. Okay? Those are all what we call connectives in the logical world. Either, or, and, but. Okay? So types of propositions, compound propositions. We have a conjunction. Conjunction. And what that is stated as P and Q. Okay, and you may see it like this, P and Q. That's the symbolic logic we're getting in. Okay, now for conjunctions of and, both statements must be true. So both P and Q must be true. That rhymes. And what P and Q are, those are different propositions. So P is a proposition, and Q is just another proposition. Proposition. And we'll see that in a little bit, okay? Inclusive disjunction. An inclusive disjunction is P or Q. That looks like pork, almost. P or Q, or both. Okay, so the inclusive disjunction can be both things as well. It is represented by this here, P, V, U. Okay, only one statement needs to be true. One or both. So P or Q or both true. That differs from an exclusive disjunction. Disjunction, which is also P or Q, not both. Okay, so I will be very specific in stating whether it's or both or just regular. And the difference between this is you have P or Q. So it looks very similar. Exclusive has the little line underneath. And this just means you can have one or the others. So P or Q, one of which is true. Okay, so do you want fries or a shake? You only want one of them, okay, for the exclusive disjunction. And a negation, negations are not, or the opposite of the proposition, and they are symbolized by this. So that's just the opposite. Okay, so what in the world is going on? Okay, the last thing here, quantifiers are a word or phrase telling how many. So all you may also see as every, you may see as each, and you may see as none. Actually, all those statements are referring to all things. Some you may see there exists, and at least one. Okay, there's more, but in general, we'll do that. So, let's see what's going on here. So, to negate a proposition, negating is just doing the opposites. So, to negate this proposition, if the proposition is, I don't want the best support, is I want a cookie, negating is just taking the opposite. So, I do not want a cookie. And I know, you guys are like, why are we doing this in math class? Well, it will build to logical statements later, okay? Some people like cheese. When we're negating, we are going to change some to all. And we also need to change the like. So this is going to become all people do not like cheese. And we are going to practice these quite a bit. All people are intelligent. We change all, so we're going to change the quantifier. So that's what I'll start highlighting is the quantifiers. So we change all to some. And the rest of the proposition are intelligent. Some people are not intelligent. That's the negation. Mike wants all of your money. Okay? So, in this case here, we are just going to change the quantifier. So, Mike wants all of your money. Mike wants some of your money. And we'll also change wants to does not want. So, Mike does not want some of your money. And everybody loves Raymond. All right, we're going to change everybody. That's a quantifier. Loves is going to be like our verb, I guess, so to speak. And we will have this. So everybody will change to some people do not love Raymond. Those are negating, all right? Seems confusing. Basically, change the quantifier. The quantifier will always be first. Well, not always, but will most of the time be first. So things like all, everybody. Creating compound propositions. Okay, so now we are going to be taking the logical statements, P and Q, and we're going to take these symbolic logics and convert it into words. So first we have, I want fries. And you'll want to get comfortable with what these symbols mean. This here is or, I want a shake. And since it's the inclusive or, you could say or both. This one is the exclusive version. So, I want fries, or I want a shake, not both, but not both. And we do that because here we have the exclusion. So they are different. When we look at truth tables, we'll see that. This is and. So I want fries and a shake. This is not P, so it's going to be the opposite. So our thing is I want fries. We're going to say I don't want fries. The negation of Q is I don't want a milkshake. Wow. I don't want a shake. Not P or not Q. So now we're combining them. I don't want fries or a shake. And this is inclusive or both. Not. So when we see this, it's a double negation. You guys have heard that in probably English class. A double negation is just going to cancel everything out. So really, it's saying I do want a fry. So I don't not want a milkshake is really I want a shake. Okay, so you could just write that out. Similar here, so negation of P first. I don't want a shake, or I don't want fries, sorry. And I want a shake. And lastly, I don't want fries, or I want a shake. Or both. Okay, so those are logic. Your homework is very similar to all these types of problems. Okay, so it's a lot of writing, honestly, but notice there are very minimal numbers. Okay, but it's logical reasoning. It'll be big when you get into proofs. It'll be big even when you're just designing arguments, and that's really the name of the game. Okay, so I'd like to see your notes. I'd like to see that you submitted them. And afterwards you can begin the homework, which is just the 111.1. There's a practice sheet. Okay, so nice stuff, guys. Thanks for hanging in there, and have a wonderful day here in Palmyra, PA.